A sidereal day is the time taken by the Earth to rotate on its axis relative to the stars. A sidereal day is 23 hours, 56 minutes, 4.091 seconds. This means that each star will rise 3 minutes, 56 seconds than it did previously. Like the islands, cities, and towns, every object in the sky has two numbers that fix its location called right ascension and declination, more generally referred to as the object's celestial coordinates. Declination is the celestial sphere's equivalent to latitude, and it is expressed in degrees, as is latitude. For declination, positive and negative refers to north and south respectively. The celestial equator is 0 degrees declination, and the poles are 90 degrees, positive 90 degrees and negative 90 degrees, north and south. Right ascension is the celestial equivalent to longitude. Betelgeuse, also referred to as Betelgeuse, is a red supergiant and one of the largest stars visible to the naked eye. It is also referred to as Alpha Orionis, marking the eastern or right shoulder of the constellation of Sahu, also called Orion. The celestial coordinates of Betelgeuse are right ascension, 5 hours, 55 minutes, 10 seconds. Declination, positive 7 degrees, 24 minutes, 26 seconds. On the other side of the celestial equator, you have the brightest star in the constellation of Sahu, its left foot, Rigel. Rigel, also called Beta Orionis, is a blue-white supergiant located about 870 light years away from the Earth and is about 47,000 times as luminous as our Sun. Rigel's celestial coordinates are right ascension 5 hours, 14 minutes, 32.3 seconds. Declination minus 8 degrees, 12 minutes, 5.9 seconds. The Earth's ellipse, which is known as the ecliptic, is the plane of Earth's orbit around the Sun. The Earth's axis is not perpendicular to the ecliptic, but has an inclined angle of 23.5 degrees. This is called obliquity. This obliquity, coupled with the Earth's orbit around the Sun, determines how we see the heavens around us. We observe the sky as a spherical surface. This is why it's called the celestial sphere. With all of this taken into consideration, the celestial latitude and longitude, declination and right ascension was established to give coordinates to the apparently fixed objects and moving ones as well. Now that we comprehend declination and right ascension, let us look at another system of coordinates known as azimuth altitude coordinate system. Depending on the hemisphere of the observer, north or south, the celestial pole becomes an essential point. As observers, we see everything rotating around the celestial poles. Imagine facing true north. Draw a line from the celestial pole until it hits the horizon. The azimuth of the object that you have identified will be the angle of its clockwise bearing from geographical north. The elevation from the azimuth is the altitude. Keep in mind that the azimuth altitude results depends on the observer's location on the planet.